let's use a model to determine a real-world scenario. So in science class, Abby mixes a fixed amount of baking soda with different amounts of vinegar in a bottle capped by a balloon. She records the amount of time it takes the gases produced by the reaction to inflate the balloon. From her data, she created this model that says T of x equals negative 0.12x cubed plus x squared minus 3.38x plus 13.16 seconds to inflate the balloon. All right, so how long would it take to inflate the balloon 5 quarter cups of vinegar? Okay, way one to do this would be, remember x is quarter cups, is plug in 5 everywhere that there is an x and find your total. Another thing that you could do, anytime I see a function, I like to graph it. So I have typed this into Desmos already. I saved you a little bit of time. I can hit this little gear here, the settings gear right there, and hit table. I could also just type in 5. So my answer is 6.26 seconds for to inflate 5 with 5 quarter cups of vinegar. Okay, so 6.26. All right. And this last part here says, I've already forgotten what this was. Sorry, 6.26. All right. What do the x and y intercepts of the graph mean in this context, and do they make sense? So, looking at my graph here, the x-intercept means that I'm looking at the y-intercept, that helps. Approximately 6.6 cups of vinegar are used. Okay. And then the y-intercept tells us that if no vinegar is used, the balloon will inflate 13.2 seconds. So, do the values make sense? That's probably debatable, because if no vinegar is used, would the balloon inflate at all? I would not think so. So there are lots of science things and different things that use polynomial models. I'm not going to ask you to make the equation from scratch, but just know that we can use them to find out certain things about polynomials, or the models that we're trying to find out about them.